Our final talk of the morning is from Michael McBride. He is presenting how to use blockchaining and networking. Mike's the Senior Director of Technology at Futurewei. He comes to us from Orange County, California, close to where I live as well. This is Mike's third time to be speaking here at NANOG. Mike spoke last on IP Multicast at both NANOG 28 and 44. Welcome back to NANOG, Mike, and thank you so much. It's a pleasure to have you back with us. Take care.
Yeah, so it's been about 20 years since I last spoke, and that was on Multicast. And today I'm speaking on blockchain. And if I speak again in 20 years, maybe it'll be a topic that people actually enjoy. I'm honored to speak after Jeff. I've been a fanboy of Jeff for a long time, particularly in the IETF. And the last few slides that he shared were just pure gold to set me up for what I'm going to talk about today, because what he was alluding to is that the networking layers are becoming commoditized, and that all the interest really is at the application layer, at layer 7, and that we're moving towards a decentralized forwarding paradigm. And that's what blockchain does. Blockchain amuses me, per Jeff's comment, and so here I am to talk about it. Standards are working on it. People have asked, blockchain, could it be used for a networking scenario? And it can be. So let's get into that a little bit. All right, so here's some of the standards that are working on aspects of blockchain. I'm very involved in the IETF. The IETF has a couple working groups now that, surprisingly enough, are working on aspects of blockchain with regards to interoperability and supply chains. I follow the ITUT as well. They've had some focus groups on blockchain. They now have one on metaverse. And in every metaverse architecture I've seen, they always have an underlying layer for using blockchain or some sort of an append-only ledger for all the assets. IEEE has been working on blockchain for a long time. They have a lot of working groups working on this with regards to IoT and interoperability as well, and data formats. I recently became involved in ANSI, part of ISO, and we're also working on blockchain standards. And NIST has some wonderful documents that I'm referring in this presentation. So it goes way beyond cryptocurrency, which I'm personally not that interested in. It's the cryptography behind cryptocurrency that I'm really interested in. A lot of people are interested in. There's billions of dollars that are tied up in the transportation industry that uses paper a lot in their transactions, and so they're looking to something like a blockchain ledger to be able to provide more security and to prevent fraud. Especially when you're shipping things. So if, sensors nowadays are very cheap. So you can put sensors on anything and then you can transmit that up to a database of your choosing. And in some supply chain groups, they're using a blockchain to do that, to secure those transactions. And they're able to monitor temperature, insurance companies like that, so they can know who to point their finger to. I even have a friend down in Southern California who's a CEO of a company called Athian, and they use blockchain and sensors to upload information about the production of meat. So from the cow through the production stage, and they actually have an additive to food that reduces gas emissions from cows. And so they're able to monitor gas emissions and upload that to a blockchain to prove for everybody to see that their solution works. So it's important to know that blockchains, they store transactions over a distributed state, and they determine who owns what, provide asset tracing, and they secure digital content. And transactions can really be any kind of data being sent from A to B, Alice to Bob. It doesn't have to be money. It can be assets of any kind. It could be IP addresses. It could be ASs and prefixes. To me, one of the more important aspects of a blockchain ecosystem is the consensus protocols. And I'm thinking that this is probably one area where a standards organization can get involved, and that is to create a consensus protocol specifically for networking. They're really the backbone of blockchains. They're validating transactions, they're adding blocks, they're constantly working on inconsistent state and making it consistent. And so there's a variety of ways to create this consensus. Proof of work is one of the infamous ways where it's solving a complex puzzle, which I'm going to talk about next. And there's that's proof of work. Proof of stake is much less energy intensive. I'll talk about that in a minute. So why even consider a blockchain besides the fact that standards organizations are working on it, and it's kind of fun to work on it. It's kind of fun to work on something other than just updating routing protocols. Well, they really are tamper evident and tamper resistant. You have all these blocks that there's all this machinery around protecting data. That's their whole purpose. And so all these blocks are chained together, and I'm going to share a diagram of that in a minute. You can't change the transactions. They're append only. In a traditional database, you can change the value, but in a blockchain, you're only appending to what's already been published. It's self-policing, it's decentralized, it's distributed, it's more resilient perhaps to attacks by bad actors. It uses cryptographic hashing, usually SHA-256, which is used to create addresses. Blockchains, the wallets, they use these hashes of public keys. It's a alphanumeric string of characters rather than an IP address. And that's also used to secure the block and the header. And it could be permissionless or permissioned, private or public, and it's smart contract capable as well. And so I think that that's a key element to this as well. And Rob at the outset mentioned that as well, is that automation is key, and smart contracts allow for automation of a network. This is from a NIST document. I need to kind of go fast through a lot of these blocks, so I'm going to kind of move quickly. I may go over just a little bit, but I'll be good. But this is basically the way that it works. Is there in orange or gold, you have the data, and that data is hashed to the block header. You've got a timestamp, you've got a hash of the previous block, and you also have this nonce that I'll talk about here in a minute. And they're all chained together. So if you try to change the transaction amount in a previous block, it's going to change the hashing, and so none of the subsequent blocks are going to agree with that, and they'll just reject it. Proof of work. So this is probably one of the more, like I said, it's controversial consensus protocols because it does take a lot of energy. The way it works briefly is that you take a string of a character, like blockchain, for instance, just that string of characters. And then you have to try to find a nonce that when hashed creates some sort of an output. And in this case, the puzzle is it need to have a result that starts with 6 zeros. And so a miner or a validator starts working through this complex puzzle. They add a 0 to the blockchain. They haven't solved that puzzle. They add a 1 to that word blockchain. They still haven't solved the puzzle. And it takes them not until they get to 10,730,895, actually 96 tries, they finally get a hash result that starts with 6 zeros. And so they've solved the puzzle. They've earned the right to take all these transactions and put them into a block. Usually that in Bitcoin's case, that's usually limited to about a meg. So that's usually about 1,500 to 2,000 transactions. They let everybody else know in the ecosystem that I've solved it. And they said, yep, we can see that you solved it. We've taken that nonce and we know that you did. So we're going to start working on the next one. And that takes a lot of energy. Sometimes you have these pools of servers that are working on solving this complex puzzle. So that's all the work that's going into this. When you have something like proof of stake, you don't have to deal with any of this. The amount of stake that you have into a system increases your chance of being chosen as a miner or a validator. So this is kind of the way it looks when you are viewing it from the perspective of a blockchain peer-to-peer network. They, kind of to my initial point and that Jeff mentioned, they don't care really much what is going on in the underlying network. They just assume the connectivity is there and that it works. It has its own ecosystem of all sorts of nodes. In Bitcoin's case, there's millions of nodes. There's boot nodes and seed nodes and validating nodes and full nodes, which can be roughly equivalent to receiving full BGP routes, and you have lightweight nodes that are only receiving the headers. And so they're just focused on their network and they secure it very well. They're hoping that the network can do the same, the underlying network. In the IEEE and other organizations as well, there are architectures that have the layering, and some of them view it a little bit different than others, but this is the one that at least the IoT group in the IEEE is how they're viewing the layering for blockchains. The session layer is where it starts getting interesting, where you've got the blocks, the transactions in the blocks. You've got the consensus layer, which again, to me, is probably the most interesting layer. It's doing a lot of work. And then you got the contract layer, the smart contracts, the application protocol layer, and the application layer. So all the interesting things are happening above what we're usually working on. This is a diagram that I found that on Medium that's probably shows a smart contract the best that I've been able to see, where you've got a blockchain developer. In Bitcoin's case, it's written in C++. In Ethereum, it's in Mobile. So if you're interested in a new start to your career and you want to try something new, blockchain development is pretty hot. But you can create these smart contracts that certain parties agree to, that when certain conditions exist, they execute, and then they are able to send those to the validators, and those validators put those into a blockchain. So these smart contracts have a lot of value, and I think they were developed specifically for Ethereum. And they can execute like, on a certain price of a stock, and then they'll kick off a sell, or it could be, when we receive too many updates, we're going to go ahead and do something with that peer. That's a quick little plug for a draft that we have. Doug Midori and Jeff Tensor and I have a draft on path prepending. And so this would be something that would be able to initiate rules based upon some of those things that we have identified in that draft. So when you're deciding whether to consider a blockchain, and some people really are using blockchains, like I mentioned in supply chains, there's some things that you just have to compare between the traditional database that you're currently using versus a blockchain. So databases are controlled by an administrator. People are okay with having a central administrator. They're client server in nature. They can have malicious actors alter data. It's happened. We read it about in the news all the time. And the administrator really is controlling everything. They're really easy to implement. We have a long history of them, and they're very fast. Blockchains, on the other hand, are decentralized. They're permissionless. It's nearly impossible to change the data. There's no central administrator. They're not particularly fast, although they are getting faster. They store their data in blocks, again, like I said, and they're append only. So do you need a blockchain? So this is also something that's been published on the IEEE site that I think is a good thing to go through to kind of evaluate whether this is something even in the years to come that you want to pursue. So some of the questions you ask is, can a traditional database suit our needs? If the answer is yes, then you don't need a blockchain. If the answer is no, then, well, do more than one participant need to update this database? And if the answer is no, then you probably don't need a blockchain. If the answer is yes, okay, so do all those potential updaters trust each other? If the answer is no, then would they all be okay with a third party? And if the answer to that is yeah, they'd be okay with a third party central administrator, then you don't need a blockchain. And then it starts getting interesting that, as far as blockchain is concerned, is does the data need to be kept private? And if the answer is yes, then probably you want to have a permissioned private blockchain. And do you need to control who can make changes to the blockchain? If the answer is no, then you probably want a permissionless blockchain like Bitcoin is. So I see a lot of opportunities, and so do standards organizations, for potentially using an append-only ledger like a blockchain to do some things that they may want to do. And we're at least evaluating it. In the IETF, we've had side meetings to discuss it. And one of the outputs of one of the recent side meetings we had was maybe a consensus algorithm. So I mentioned proof of work, solving a complex puzzle, a lot of energy. Proof of stake, you're chosen as a validator based upon how much stake. There's delegated proof of stake, which the people vote on who's going to be the one that actually inputs the transactions into the new block. There's proof of elapsed time, which is more of a trusted execution environment and using hardware and having a time period. Interoperability is being worked on today in a variety of standards organizations. I'm going to talk about that in detail in a minute. Integration with network functions, I'm going to talk about that as well. I was recently reached out to by someone in the IPv6 forum about using IPv6 for blockchain. As I mentioned, blockchain uses these alphanumeric values that come from hashing instead of IP addresses. So maybe we can use IPv6 to make some changes. There's metaverse, which, again, it's ITUT and others are getting kind of serious about architecting for that. And you can purchase a blockchain as a service today from any number of cloud providers. So interoperability, just real quick. So today, if Alice wants to send something to Bob, you have an exchange, period. If you want to send an asset of any sort, and most of us appreciate having a bank or something as a central authority. I know I do. And so that's the way it works. But there are working groups throughout the industry, particularly the IETF, that are working on actual interoperability between different blockchains. So if you take a Bitcoin blockchain and an Ethereum blockchain, or maybe a Ethereum blockchain and a traditional database, there's no way to send data between them without some sort of intermediary. And so we're working on a protocol between gateways. The gateways have to be secure to allow the transfer of assets from one network to another. And these networks are opaque to one another. They don't have a clue what's going on between them. This comes from the architecture draft. If the originator wants to send something to the beneficiary, and you've got these gateways and this SATP protocol, that's a secure asset transfer protocol, the first stage would be that the originator wants to send something to the beneficiary, and they make that known to one another, and they say, yeah, we want to do that. Stage one is by this protocol is pre-verification of identities and assets. Then you lock that asset, so there's no double spend. And then the final step is to commit a unidirectional transfer of an asset. And if there's a collision or a crash during this time period, then there's a protocol that allows you to go back to where you were before the crash. The second working group in the IETF that has a component of an append-only ledger is SCIT, the Supply Chain Integrity, Transparency, and Trust. So they're working on, first of all, they were chartered to only work on software bill of materials, but in their architecture, they have an append-only ledger, which could be a blockchain to store assets. So there's a variety of these network opportunities that we're identifying, and we're putting them in drafts so that we can at least use them in the future if they become valuable. If you're collecting data from a packet capture device, sending them to a server, if you're concerned about those servers being compromised, you may want to send that data to a blockchain, because then you know that it's not going to be compromised. So network management could potentially move to a more decentralized smart contract system. You could sign routing advertisements. You can provide the all elusive proof of transit, which we're having a hard time providing. You can store ROAs in a blockchain, much like how RPKI does out of band to BGP, And it's important to realize that all the network opportunities we're seeing and we're working on are all out of band to routing. They're not getting involved in the control plane. Overlays such as Lisp, Locator ID Separation Protocol, have been used for blockchains to find the best DLT peer. For those of you that know Dino Farinacci, a longtime IETF guy and a wonderful engineer, he did this very same thing for a blockchain solution. Blockchain email is actually, those are real solutions that have been out there. Many of them are rolling out. There's many prototypes, and they're doing a variety of things like in storing email addresses in blockchain, storing all of your emails in a blockchain, so only you have access to it or can see it. It would be a private blockchain. If you forget your private key, however, then you're out of luck. There's no way to access your emails anymore. There's nobody you can call. So there's some good, amazing work that's going on there. So this is the draft that we've been collecting a lot of these ideas into. And there's some good opportunities, I think, that we've identified. The way it would work visually is if you look in the right-hand side, it's kind of the way that we kind of envision BGP peers out of band to BGP sending their BGP information to a distributed consensus system that's focused on routing. It could be BGP, and have a smart contract that is validating certain BGP updates. And, you know, if BGP really is a, you know, if we really want to secure it, then maybe this is another way that we can do so. And you could have a BGP blockchain table, and you can maybe provide that path validation that we're always looking for. So this may cause Jeff and others to lose some hair and get a little bit anxious. This is definitely pushing the envelope, but it is realistic. So you have these RIRs that have their own databases today, and they're making ROAs available, and they're maintaining things very well. They could very well, in addition to or instead of, I know that's blasphemy, but they could potentially use a blockchain to store their all this information about prefixes and ASs. Today, you've got a validator in the RPKI world. You could also have a validator that has some sort of a full or partial routes. And the routers, like today, where you can do a show validation database, they have in memory where they can see the RPKI data to look at before they accept updates. You could do something similar using blockchain. I probably wouldn't say that you would ever use a blockchain on a router, but somehow out of band, you can have a router that looks at the blockchain table. This is a quick look at a state transition function. This is straight out of Ethereum documents. The way it basically works is for each input into a transaction, if the referenced asset is not in S, and if S is sending something to S prime, return an error. Or if the signature doesn't match, return an error. Or if the sum of what is being sent to S prime is not equal to what was sent, then return an error. Else, return S with all input removed and all output added to S prime. And so you could do something similar for BGP. I'm kind of spitballing here a little bit, but you could do something like, you know, change that state transition function to if the referenced prefix is not in S, return an error. If the provided signature does not match the owner of the prefix, return an error. Else, accept the prefix and add it to a blockchain table or a smart contract. We're also looking at the impact of DLTs. It's important to know that you've got all these potentially thousands of peer-to-peer nodes and all these TCP connections across your network to know what's going on. And so I don't have time to go into this, but we do have a draft that does. And Dirk Trossen and his team in Germany is working on this in great detail to find out, you know, really what the impact to networks is when you have a blockchain running over your network. And Bitcoin, for instance, uses TCP port 8333. So if you want to block it, you can do it. And so it goes over some actions and communications patterns and the challenges of DLT and networking. And I had to get a slide in on multicast because that's just kind of my heart and soul. But we've been thinking that maybe there's some ways that we can use, since it's very point-to-point nature, that there's some ways of using multicast, but it's challenging because it's the peers and the pools of peers are very dynamic. Last two slides. So the reality check is, and I'm trying to just kind of give an honest appraisal of this technology, is that immutability, which is I've used that word, and that's oftentimes what we hear about with blockchains. It's not strictly true. Sure, you can't change something that's in a database, but the creators of the blockchain system could. And it's happened a few rare times, like Ethereum has made a change in the years past to roll back to a previous instantiation of the network because of a lot of people losing their assets. And so it's not strictly true. An Oracle problem, so an Oracle is something outside of the blockchain system, taking data, could be sensors that I mentioned earlier, and inputting that into a blockchain system. So you have to trust that Oracle. And so that's a potential problem. Transactions, before they're added to a block where they're very secure, before that stage happens, they are vulnerable. And so that's a particular area that is a potential for vulnerability. Miners that are publishing blocks, they could be malicious. There's some things that you can do to help protect overcoming security with mining, but they could potentially be compromised. They could just refuse to forward data. And so that's a potential problem as well. Yep, we in blockchain, you very much trust cryptographic technologies. They may not, that implementation may have some problems, and the resource usage that I mentioned earlier. So this is the summary. So SDOs, they are specifying blockchain standards, and that's why I'm interested, and that's why several people are. Blockchains are the backbone for crypto assets, but that's not of interest to most of us. Most of us are primarily interested in other use cases of blockchain, and we're at least doing due diligence to evaluate the technology. Could be some opportunities for using blockchain and networking. Here's several of them that I've mentioned, DLTs do have an impact on a provider network, and we're still trying to figure out what that is. And with that, thank you very much. Any quick questions or comments?
Maria Cizatnik again, developer of BERT. I'd like to ask you a very simple question. Are you advocating for destruction of RIRs in favor of replacing these with an extension of basically Git, which we are using every day? Or are you asking for just everybody to use Git? And was it so necessary to speak about that for such a long time? Thank you.
Yeah, so good question. We're not advocating for anything. We're evaluating potential opportunities to use blockchain and networking. And I think personally that in being that RPKI is outside the routing system, that this is a potential opportunity, and there may be other types of solutions that are also out of band to routing that could equally or even better perhaps secure routing.
Yeah, my question is about the proof of a state. Do you feel that is proof of work more secure than proof of state?
Yes, proof of work, I think, is more secure than proof of stake. It takes a lot more resource to secure the blockchain. Bitcoin uses it because it's wide open, it's permissionless, anybody can join, so they kind of have to do it. Ethereum decided to switch from proof of stake from proof of work to proof of stake because of resource usage, and they're finding that it's equally as secure, but it probably is a little bit more vulnerable.
Yeah, and my other question is about block DAG. Are you running to block DAG like an alternative for blockchain?
Say that again?
Block DAG?
Blockback.
DAG, D-A-G.
Not familiar with it.
Okay. There are new cryptocurrencies using it right now.
Okay.
Thank you.
Thank you. All right, thank you very much.